Good morning, everybody. So, this session is going to be a little technical, but then, please, you can shoot questions if you're kind of getting stuck, okay? So, today we're going to talk about Open Interconnect Consortium. This is Ashok Subhash. I'm talking on behalf of Dr. Alok Nabde, CTO of Samsung R&D Institute. Okay, so today's agenda, we look at the overview of IoT. I think everybody knows what IoT is. The various standards consortia, we'll have a quick walkthrough, okay? And then we look at OAC IoT stack, the topologies and the protocol supported. Finally, a little high-level architecture of IoT architecture, and we'll summary. Okay, so everybody knows, so the Internet of Things is the network of physical objects that contains embedded technology to communicate, sense, or interact with the object's internal or external environment. Okay, there's a nice definition from Gartner. Okay, and with respect to what do you say, domains, we have lots of domains: connected car, fleet management, smart home, smart city, healthcare, wearables. I think IoT is all pervasive. Okay, so we'll see that. Okay, this is the IoT business opportunity that came in McKinsey's report in November. Okay, you see there's a lot of potential for IoT to make money. So that is the predicted revenue verticals. Okay, there is an important point. If you look at this point, interoperability is required to capture 40% of the total value. So that's going to be key for IoT. Okay, and then as of today, it's only less than 1% of the data from the devices or sensors from across devices which are used. Okay, so the moment all this sensor data can be collected, there are a lot more use cases. I think Mr. Bernard mentioned about predictive analytics, predictive maintenance, etc. There are a lot of things to be done. Okay, so quickly we'll skip the number of IoT units installed. This is the latest thing from Gartner. Okay, so we look at the various categories: consumer, business cross-industry, business vertical specific. Okay, when we say business cross-industry, which are common across variety of industries, okay, like building automation system, HVAC, so things which can be used across industries. Vertical specifics are something specific to a particular vertical domain. Okay, it could be healthcare equipments or special tracking devices. Okay, so that's the point. Okay, before we move on, okay, so this is a quick run through of who are the IoT players in the value chain. Okay, you have the services people, the chipset vendors, the device manufacturers, the infrastructure providers, and then the OTT players. Okay, okay, I should not have shown this. Why do you think? There was a nice reference of Kevin Ashton that the Internet of Things term was coined in 1999. But what's making IoT possible now? Probably people had a look at the answer, but I want some quick answers from the audience. What's making IoT possible now? Mobility, yeah, part of it, but the core things that is making IoT possible? Internet has been there for the last decade. Okay, can we close the door, please? Because otherwise, I think a lot of noise. If you can come inside, it'll be great.
Yeah, I think quite a number of things. Whether it is wireless, more communication is happening now in wireless than wired. Whether it is the proliferation of sensors whose cost is so less, or whether it is the reduction in the cost of storage. You know, a gigabyte is hardly 5 cents when it was $400,000 in 1980. So, you know, what it really means is you have a lot of sensors, you capture a lot of data, you transmit it cost effectively, bandwidth is growing, you know, 42 Mbps, blah, blah, blah. So all this is...
Sure. I think you summarized it all. So the hardware miniaturization and the lower BOM cost, because the miniaturization part is pretty important because you can put it on all the things at your home or wherever it is in industrial scenarios. It has become really small, and of course the most important thing is what is the ROI. So can I do it with a lower BOM cost? Okay, advancements in sensor technology. To give you a quick update, in a typical flagship product from Samsung, the more than 20 sensors. Okay, but if you take a connected car, I think a lot of people are from the automotive domain. I think it's more than 1,000 sensors. Okay, which kind of checks the various states of the systems. Okay, so the advancements in sensor technology, Longer battery life, battery technology also has improved where I should be able to run a device on a coin cell battery for more than, say, about 10 years, okay? That is one thing. Low power connectivity technologies. This is also very important. Some of the low power connectivity technologies anybody is aware of? Zigbee, Z-Wave, 802.15.4, okay? There are lots of low power connectivity technologies which is very important. This to me is one of the key thing, okay? IP is a key interoperability protocol. That is why we are enjoying the success of internet these days, okay? So that's very important. And of course, Bernard touched upon machine learning and intelligence, artificial intelligence. So that is also one of the key factor for. Okay, so this again I showed you that. So what's hindering IoT these days? Quick answers I need. That's not. Okay, security is a key problem. Security and privacy. Anything else? Multiplicity of standards, very, very important. Yeah, so there are a variety of standards. So again, the notion of interoperability, that's why I said interoperability is key. Okay, if we don't come up with, but practically it's not gonna be a single standard, but at least some few sets of standards which connects all the things, nodes in the internet so that you get the real benefit. Anything else? Sensor calibration, that's not hindering. Sure, there are problems, but accuracy rates are becoming higher and higher. That's not really a problem. Anything else? But that's the point, right? I mean, that's okay. Sure. Okay, that's. I would say I'm not saying it's wrong or right. Probably we'll have to really find. Okay, I invest so much. Okay, whether the automation enables me to save something, but I think we have lots of case studies presented in the keynotes where it's saving us in terms of efficiency, productivity improvement. There is going to be ROI, okay? So IT, not just the hype, there is a lot of potential as well. See, that's about business models, okay? So that will evolve. I mean, you're right, probably. So that will evolve, but we'll find it soon. I mean, wherein everybody benefits. Every vertical domain is going to be benefited by IoT, okay? So yeah, I'll just quickly move on. I think we already covered fragmentation, okay? And then security and privacy, okay? Device and data management. How do you provision the devices? How do you onboard the devices securely, okay? And then this is something which is important, okay? Today we have run out of IPv4 addresses. There was a recent article, US no more has public IPv4 addresses to shell out, okay? Now IPv6 deployment is mandatory if IoT is going to really make a difference in people's lives, okay? So that is also one of the key thing as we see. Then we have, see, typically we have what are called the self-healing sensor networks. There are standards, companies working on this to do this self-healing sensor networks in your proximal networks, okay? Then we have the concept of heterogeneous network where there are multiple connectivities, but then, so one device might have Zigbee, another device might have Z-Wave, another device might have 802.15.4. So how are these devices going to communicate with each other, okay? So that's the point. Okay, so now we'll quickly move on to the, what are the various IoT consortia. Okay, so this is what is Open Interconnect Consortium. So here we are defining the connectivity standards, okay. So there are plethora of connectivity technologies, but then I need a communication frame which is common. Today's internet is successful because you have TCP/IP, HTTP sitting over it, which is defining the transport. That's why we are enjoying the benefits of internet. The same thing needs to be done for IoT per se, okay. So the key focus of, we'll cover this in detail, but currently you can think of it as standardization at the connectivity level, connectivity standard over the actual radio technologies, okay. So that is what it is. We'll have a look at it. I have to mention our another competing ecosystem, Allseen, driven by Qualcomm, Microsoft, okay. They're also trying to solve the same problem. Industrial Internet Consortium, okay. So here they are not really creating standards, rather they are defining a reference architecture, okay. From all today's presentation, I think the focus is on Industry 4.0. So, I think it's primarily coming from European countries, Germany, but industrial internet consortium is driven by the American counterparts. Okay, so that is a close relation if you could see Industry 4.0 and industrial internet consortium. Okay, one M2M, again they define a common M2M service layer. IPSO is again trying to establish IP as the basis of connection for all the smart objects. Okay, so this I have to touch upon. Thread, where Google in the sense Nest is kind of Nest Silicon Labs, and of course Samsung, they're all driving the standard, where when I talked about mesh network, low power self-healing networks, so this is the focus of this is on the networking part of it. Okay, we'll see, we may not have time to go deep into the technology, but you can catch me outside the presentation so that I can explain you more. UPnP, aware of, I think some of your houses already has UPnP technologies. DLNA is one where you can communicate with your TV, etc. So that's the UPnP standard. So this is not an exhaustive list, but I have mentioned other than the Industry 4.0, these are a major IoT standards consortia which are trying to solve specific problems. Okay, so we'll have a look at Open Interconnect Consortium in a little bit of detail. Okay, so actually, I should have, okay. So the focus, okay, OIC, as I said, is Open Interconnect Consortium. It is, it's a consortia standard founded by Intel, Samsung, Cisco, GE, and MediaTek. They are the founding companies, and we have around 50 plus members who are contributing to the standards and the code. Okay, so the key, so the difference between OIC and All-Seen is, All-Seen gives you a open source which is trying to solve a device-to-device communication problem, but there's no existing standard. Okay, so in the sense published by say IETF or 3GPP. Okay, so the key difference between OIC and All-Seen, if you say, which is trying to solve the same problems. Okay, the key, OIC provides you the standard, a standard and a reference implementation. Okay, so if a vendor wants to implement his own version, his own implementation, then he can go ahead and do, because that's important, because some companies know what they're good at. Okay, so they don't need to depend on just the source. So there is always a standard for them to trace back. Okay, so you could think of that as a key difference between how OIC is contributing to IoT standards and All-Seen. Okay, so here I'm just touching upon IoTVT. So as I said, it's an open source framework as part of the Linux Foundation. Okay, it is implementing the OIC standards. Okay, the current focus is going to be on device-to-device interoperability. Okay, and then it is licensed under Apache 2.0, which is developer-friendly, company-friendly. And already IoTVT is available on multiple platforms, including Tizen. Tizen is a platform, again, Samsung and Intel are working together, okay, which is positioned as OS of everything. Means the same platform should run across variety of plethora of devices, from a smartphone to a low power sensor nodes. Okay, so you have a wide gamut of devices with different capabilities and constraints. Okay, so that is what Tizen is all about. Of course, Android, the popular OS. And Arduino, so when you're talking about low power sensor nodes, yeah, so these are some of the developer platforms where you can prototype your product. Okay, and then of course Linux on Ubuntu version for your development. Okay, so you can note down the link. I'm not sure, I think it will be shared later, so you can have a look at it in detail. Okay, so little more technical view. Okay, so as I said, you have all the connectivities. So the focus of IoTVT is going to be on the IoT framework. Okay, at a high level, how do you discover devices? Okay, how do you transmit the messages across devices? How do you do device management? Okay, when I say device management, it's about, okay, I bought a new device. How do I onboard the device onto the network? Okay, securely. Okay, how do I share the Wi-Fi credentials? Okay, so what security algorithms that I use so that a hacker does not hacking during that process. Okay, so that is primarily about device management. I have not highlighted because that's not our current focus, but that's going to be the focus for when I say data management, how do you collect all the sensors from various devices, upload it to the cloud, do some analysis, and then give some meaningful insights, okay? Of course, this, our idea is to make this component and open source it so that people can, developers can contribute and companies can enhance it for their own use cases, okay? So that's the idea. Okay, without security, it's going to be very difficult. IoT may not be a success. So security is thought from the conception, okay? So with respect to the application profiles, okay, application domains, vertical domains, current focus for us is on consumer, okay, specifically smart home and smart office solutions, okay, but later we'll also work on enterprises, industrial and automotive and other use cases. Health, already we have started some work, but that's the idea. So we would like to have a common solution, means which is a solution that is applicable for variety of vertical domains, okay, and runs on variety of platforms, okay, established protocols. So we don't want to reinvent the wheel, okay, we want to use already standards which have come up from IETF, for example, CoAP, okay, it's a constrained application protocol. You can think of CoAP as HTTP, okay, for a constrained network and a constrained environment, okay. Security and identity, everybody understands. Standardized profiles, okay, this is an important area. So when I want a Samsung phone to communicate with the Philips Hue bulb, okay, so how do this is the area which is fundamental, which is the communication framework, but if I want to control a device, okay, so I need to standardize at the application level as well, okay. So that is also one of the focus of OIC and IoTVT, okay. So that is how we achieve interoperability, get other companies on board to grow the ecosystem, okay. And then interoperability, I just mentioned. Innovation opportunities. So how do we give innovation opportunities? If you take any device, at least the basic operation you already support, okay. This is a hypothetical example. Say for example, light means I can switch on, switch off, okay. Probably I can dim. But if I want some light which flickers based on the beat or the audio, okay, just to make sure you understand what is the innovation opportunity, you can extend, that's a vendor specific extension that you can do over and top of the basic operations that needs to be supported by OIC. Okay, so necessary connectivity, because each connectivity has its own pros and cons in terms of power management, in terms of range, in terms of cost, okay, so that's going to be important. Okay, so the topology is supported. See, what kind of use cases are we talking about? As I said, the primary focus is direct P2P connectivity. That means a refrigerator at home should talk to your mobile phone, or probably some other, say, AC should talk to the temperature sensor so that it adjusts the temperature automatically, right? So that's a P2P direct communication, okay? This is something which is very important, and I think this is one of the cool use cases once we see smart home coming in another very few years time. Already I think America and probably Europe is having smart home devices, many devices, but probably India it will take few more years for a mass deployment. I'm not saying it's not already available, but for at a cost where everybody can afford, I think it's going to take maybe few more years. Okay, so coming to this use case of remote access, okay, I would like to control my devices at home from a remote area, okay. So that's the topology that is supported. So we expect there will be a gateway, which we call it as the OAC intermediary, which gets connected to the, you can think of it as a cloud, XMPP, and then stun-turn-ice for the security part. And then this OAC client, I'm telling a lot of terminologies, but you can think of OAC client as the smartphone, which you use basically to control devices in the network, in your home network, okay. So finally, this is very interesting, wherein cloud-based intelligence services, okay. I have a nice OAC vision video, but because of lack of time, I cannot play it, okay. The idea is, for example, if there is a cloud service which keeps monitoring the weather of your particular area, okay. So the web company or the developer develops virtual sensors, okay. So they basically talk. Okay, the temperature has gone up, okay, it tells the gateway, now is the temperature for you to water your garden, okay, it automatically opens the sprinklers, okay. So this is already, a lot of things are happening. If you see, Nest does a lot of work in terms of controlling your tariff, for the energy that you use at home in the US, okay? So for example, if you use power during the peak time, the tariff is probably more. For example, if the demand is more, okay, at a particular point of time, okay, so you're going to, what do you say, you're going to pay more, okay, but as a customer, I would like to optimize on my energy cost, okay, so if I can have some interesting services which can communicate with my smart home devices, I turn off or turn on my home devices like laundry, etc., when the tariff is low, okay, so there can be plethora of services that can come up once everything falls in place. Okay, I think I'm in the last slide, so to go a little more technical, as I was telling, okay, so see, when we talk about constrained nodes, okay, first is you see a change, IPv6 is going to be there, okay, since IPv6 was meant for a internet kind of an environment where the bandwidth is huge, but that's not the case in a constrained network, be it industrial or be it smart home kind of environment, okay, so you have standards like 6LoWPAN, which basically compresses, and then basically fragmentation and compression are key things, so that the IP packets can be transferred over the MAC. When I say MAC and PHY at a very generic level, but based on each connectivity technologies, they kind of have their own stack, okay. So also you see here, every connectivity technology are moving to a thing called mesh, okay. So if you as of today, probably Bluetooth does not support a mesh kind of network, but standardization is in progress in BT-SIG, where the devices can route packets like a typical routing that's available in a Wi-Fi or a Ethernet network, okay. So you can route packets in a heterogeneous mesh, okay. So here LLN stands for low power and lossy network, okay. So 802.15.4 supports both star and mesh, but going forward, mesh is going to be key for realizing many of the IoT use cases, okay. So this is just a comparison of how the OSI models onto the current constrained node stack, okay. So that's about it, I think, okay. So these are the current members I told about, okay. So we have the diamond members for the OIC, and then the platinum members, and a lot of other companies working on it, okay. That's about it. Do I have time? How much? Done. Okay, so I'll take 2 questions at least. Okay, yeah, please. Yeah. Probably I had to rush through, but since I had 20 minutes, so. Okay, so everything is clear. Yeah. Sure. So if I understand, correct. So that's what. So the point is, yes. So that's what. If you say the key contribution of OIC and IoTVT is not to depend on a particular connectivity technology per se. Okay, because different use cases demand different connectivity technologies. Okay, BT has a range of 10 meters, ZigBee has a range of 100 meters. Okay, now if you see long range, there are lots of standardization from 3GPP. It's called low power wide area network, because the current cellular networks does not support that low power part, right? I have to transmit and receive, okay? So cellular IoT is next big thing, and 3GPP has a lot of focus. So that's what, so the idea is to come up with a communication framework irrespective of the connectivity technologies, okay? So that's the problem that we are trying to solve, okay? Yeah.
I have a question.
Sure.
This is regarding the virtual sensors that you talked about.
Yeah, sorry.
Can you just give me a, I didn't quite understand what you meant by virtual sensors.
So idea is, like for example, we have various sensors at home, right? Temperature, humidity, moisture sensors, etc. Okay, they are all physical sensors, which is sensing the physical environment. Okay, but then our web services are huge. Now, for example, we all use AccuWeather, right? So now I told you that use case, right? If an AccuWeather developer or the company, okay, writes a IoT app, okay, over and top of OIC, in IoTVT APIs, okay. So what it's going to do is it's going to fetch from its web service the relevant data and push it to the gateway at home, okay. So now you can apply all the use cases. I just gave AccuWeather, okay. think of it as energy, like the guys who monitor the power tariffs, okay? So whatever web services are available, how do you bring on to the IoT ecosystem? So that's why it's not really a physical device, even though the ultimate thing is physical, but you're getting the virtual sensors on board so that it's a real value add. Yeah.
So, I got a question.
Sorry, this lady had a question last. Yeah. So that's what I said.
From all seen, is there something like that?
Okay, so the standard between your sensors and the gateway is already well defined. That is based on CoAP, okay? So Constraint Application Protocol, that is an IETF protocol. And between the gateway and the cloud, okay, the best thing is of course HTTP, okay? But then CoAP's advantage is it's a binary protocol, it's bandwidth efficient. So we are also working on the gateway to the cloud as a CoAP connectivity. But the challenges that we face are, it's been almost 2 decades where we have solved deployment related problems using HTTP. So we will face deployment related issues when you have CoAP, like for example, NAT, sun, turn, eyes, whatever is there. So that's going to be there, but the advantage is I'll use lesser bandwidth.
Okay. So just one last question.
Yeah. Sure.
The standard that you have between all seen and IoT VT, when you see that sort of converging to be one standard, because typically we have the standards when things start off and it takes time to converge on. So when do you see that trend converging?
I mean, I'm not an official person to answer that, but then I think there are developments that might happen, okay, because it's not, see, we would like to be fully open. We like to be fully open, so we don't want any IP licensing issues, stuff like that, which Allseen has as of today, even though they say it's not a problem. So I just wanted to mention, I think everybody knows about FRAND, fair and reasonable usage of IPs, so that if you make a product out of that standard, you don't need to pay royalty because you used an OAC standard. But there are some issues, I mean, don't take it. Allseen also is saying we will give it, but there are things that might happen, okay, but as of now, I don't have an official answer, okay, that it will converge or not converge, but might happen. Yeah, I think I'm sorry,
Thank you, Ashok.
Thank you.